So welcome everybody, and thanks for coming. So my first question to you is, how many of you do work with AWS on your daily basis? Please raise your hand. Okay, not so many people, so I will try to be as simple as explain the concepts here as simple as possible. However, if you don't understand anything, just please feel free to interrupt me. The presentation is for you, and I want to give you the whole idea. So through the years, a lot of company networks become like a real stronghold. So we weaponize it with a lot of boxes like IDSs, CM systems, DLPs, etc. And then there's the decision that we're going to cloud. There's completely no relation. So even the security team is not sure if their company is doing something in cloud. And it's often totally, so the logs are not related with the CM systems, no monitoring, nothing. So I asked one manager whose architecture looked like this, and I asked him, aren't you feel scared of such architecture? Well, that's just a testing environment, and our guys really know the stuff. And really know the stuff is pretty brave assumption. So basically, the access to their cloud infrastructure is protected via the access keys. And those access keys can leak in various ways. The most common way, of course, is via the hard-coded code. So there were so many leaks, there are still actually, that GitHub created a service that is called GitHub token scanning. So once you commit hard-coded keys, then the provider of those keys will be notified, and then you will get a notification from the provider. So in fact, you can do the same experiment on your own account. So once you commit hard-coded keys, then 55 seconds later, you will get an email from Amazon that your keys are compromised. But but the problem here that those keys aren't blocked. So you are just got notification. And after about 2 minutes, the first attempt of using the keys is happening. But as I said, this is not the only way how the keys can leak. And finding the keys is just the beginning for the attacker. And in this presentation, I want to show you what attacker can do with those keys and how to find it in other way than just in the GitHub repository. My name is Pawel Rzepa. I work in a company called Securing. On my daily basis, I'm doing penetration tests as well as cloud security assessment. And taking my experiences and some of real stories, I created my own story for this presentation. So imagine there's a company which is a software house, and the manager was asked by one of their customer that there's a super lucrative project, but one of the requirements is building this project on AWS. So the manager come to the team and ask about the expertise in AWS. So the team said very honestly, well, we don't know it. We don't have experience in that. But some people cannot say no to when they say money, when they see money. So the manager find an idea that maybe we can migrate our testing environment into cloud, so people can learn on the real examples, not like labs or during the certification process. So yeah, cool idea. But the team said, well, maybe we should think about it. We should plan it. We should do some trainings for our team. But there are currently there are a lot of people who are who super believes in all those motivation quotes or the books about the success, and the manager was one of them. So the manager find on his Facebook wall the quote, "If someone tells you you can't, they are showing you their limits, not yours." So the decision was made, and then any argument was rejected by the manager. So the guys built some infrastructure. They created the Elastic Compute Cloud instance, which is basically in AWS terminology, it's like the virtual machine in the cloud. So on this virtual machine, they built the continuous integration, they installed continuous integration application. In this case, it is the Jenkins. And this Jenkins will be responsible for deploying new virtual machines with provisioned new versions of the application. Make sense? And to be able for the Jenkins application to deploy new instances of Elastic Cloud Compute instances, they have to have some permissions. So you can attach the role to this instance and give them permission to deploy new instances. And this instance profile is kept in metadata. Also on the same instance, they also provision the first version of their application. So what is the metadata? Metadata is the information about your instance. So all of internal addressing, instance IDs, host name, etc. All of them are kept in metadata. Now, do you see anything special in the address 169.254? What is it, this kind of address? Huh? Sorry? It's a link local address, actually. Yeah, link local address. What means it works only in one network segment. So if you are curling to this address HTTP 169.254 from the inside of the instance, you will get all those information. But if you are trying to access this address from the other instance, you will access this instance metadata. So only you can reach the content of the metadata only from the inside. And this concept is nothing special for AWS because Azure and GCP is using it also. What is more, if you attach any profile to this instance, the security tokens, the access keys, and the secure token is kept also in this metadata on this URL. Okay? So, the story has also the dark side. And in the other end of the internet, there's the evil hacker man. And the evil hacker man found the application. So, well, yeah, okay, yeah. So it's under the address domainanalytics.org. He found the application. You can type the domain name or the IP address there, and you will get the security artifacts related with this particular domain. So, for example, when you type the one of Polish government website, you find that it is registered in Cloudflare and it expired in 2017. So it was it shouldn't be any surprise that in February of this year, someone hijacked this domain and put pornographic content. Well, as you can see, there's the parameter domain and the domain name or the IP address. What is more, if you know the IP address, then you can check what AWS service is using this address. So for example, here using the AWS EC2 reachability test, you can find that actually this web application is running on this on the EC2 service. So for the evil hackerman, it was enough to try find some vulnerabilities related with cloud. So instead of giving the domain address, he tried to put the metadata address, because the source of the address was the instance, not the attacker, right? And one by one, carrying the next endpoints of metadata, he could get all those informations. And so the vulnerability is called server-side request forgery, right? And the SSRF or RCE in cloud have totally new life. So he found that there's the EC2 role, and the EC2 role, and get the credentials for the EC2 role. Now, as I said, for the attacker, finding keys is just the beginning. So, to sum up, he found in the web application, which is hosted on EC2, he found the SSRF vulnerability, which allows him to get access keys from the metadata. And this example wasn't, it's not the lab example. Actually, it happened in real life. So there's the website called threatcrowd.org, and indeed there is the domain parameter, and the attacker put the white hat attacker put the address of metadata and got all the metadata content. So he reported it. There should be a link. If anyone is interested later, I can share the presentation, so there are all those links. So here's should be the link to HackerOne report, and guess how the people from ThreatCrowd, how they fix this issue. Any ideas? Indeed, yeah. Bravo. They simply blacklisted this IP address, but well, I think it's nothing new for the security guys, that that the IP address can be represented not only in decimal form, but you can also type it in hexadecimal or binary, and it will also work. So he got 2 bounties on this bug. Well, but going back to the story, when the attacker gained the keys, then there's a tool called PACU, and it is AWS exploitation framework. Do you know Metasploit? Yeah, so basically PACU is something like Metasploit, but for cloud, specifically for AWS. So you have a lot of modules, which are modules which are attacks. So you can just, instead of typing everything from command line, you can simply just run. I will show you a few examples, and the attack will happen. So, quick demo of PACU. It's written in Python 3. You can name the session, so each session will be separated, and the findings. And yeah, so you can list all the modules. You can of course create your own. And all the findings are stored in the data. So instead to avoid having the mess on the console, you can then you can refer to each finding, and you can import the keys. So all the requests, all the attacks will be done with the permissions of found keys. So let's import the keys. I name it EC2 pivot, because you can import several key pairs in the same session. Yeah, let's set the region, because based on the IP address, you know, not only that it is related with EC2 service, but also which region is used. And here's the list of the modules. So there are modules for enumeration, there are separate modules for escalation, as well as exploiting some misconfigurations. Don't call it vulnerabilities, let's call it misconfigurations. So, using the PACU, you can enumerate all permissions if your role allows you to. However, if you don't have enough permissions, you can always brute force each command and verify if you have the access to it or not. In our example, then the name EC2 role, well, it indicates that probably it will be related with EC2, right? And it is super common, well, what I see when I'm doing cloud security assessments, it is super common the developers use the wildcard. Why? Because it always works. So instead of give the granular permissions to each account, it is much easier to put the wildcard. Nobody says anything. It works, right? So it's doing the job. However, of course, it is in 99% of use cases. This is too much. So in PACU, there's the EC2 enum module for enumerating all the instances which are reachable for these particular access keys. And then you can display all the data using data EC2. But I don't want to get you fall asleep with all this content. So the most important findings during the enumeration was that there's one more instance which is stopped, but this instance had the attached profile admin instead of EC2 role. So again, it is pretty indicative that this profile probably will be what the attacker should look for. So we have the EC2 permissions, but how can we access this instance? It is stopped, but even if we start it, how can we access the admin profile if we don't have SSH keys there? Any ideas? Download the instance. Oh, I don't think it's possible in AWS. The snapshot, yeah, but yes, but then not only EC2 permissions are enough, because you need to have assume role permission to give this admin profile permission. There's a concept of user data in EC2. So the concept is that you can specify a list of instructions that will be executed on the boot time, but the limitation is that it will be run only once. So, for example, you can specify there that once the instance will be booted, then it will download all the newest code, install some updates, etc. So, pretty nice feature. But of course, attackers can use it for themselves. There's a nice trick in AWS that you can add the directive of Cloud Boot Hook on the beginning of user data. And if you do so, then those user data will be executed every time the instance is restarted. Okay? So if you change the user data and with EC2 permissions, you are allowed to modify the EC2 attributes, so user data too, then you can simply put a reverse shell, the bash one-liner, without installing anything from the external sources. And here you are putting the attacker public IP address, and here the port number, the port number on which you are listening for upcoming reverse shell. So, once again, you are getting the EC2 role, then using the EC2 role, you are modifying the user data, you are restarting machine, and once the user data is executed, you are getting a reverse shell, and you are king of the cloud. So, how does it work in practice? In Pacu, there are just few clicks. Well, so let's use the exploit, which is called EC2 startup shell script. Let's display the help to see what parameters it should take. So you are giving the script, so to override user data and the instance ID, to know which instance should be, should have overwritten user data. So in this terminal, this is the attacker terminal. So there was displayed the IP address, and this is the reverse shell which I want to override with user data. Now I'm setting the listening port, and in other terminal, also on the attacker side, where you have the Pacu session, you are simply running this module with the ref shell script and related with this instance on this region. So what you see is that the instance is stopped. The user data is modified because the user data can be modified only when the instance is stopped. And then you are starting it. And because of the cloud boot hook directive, the user data will be executed. So here you can see that we are waiting. The instance is starting not so fast. Those who work with AWS know it. So we have to give it a little bit time, but then, bam, we have it. So we gain the reverse shell, and now again using the same trick of accessing the metadata, we are getting credentials, but this time of the admin profile. Is it the end of the cyber kill chain of getting the administrator? Who thinks that yes? Please raise your hand. Indeed. Good, good. That's just the beginning. So what the attacker wants is to remove his fingerprints, right? In AWS, there's the CloudTrail service, which is responsible for monitoring all the regions and all the API calls. So whatever your developer, whatever he will do, it will be monitored by CloudTrail, and it will land in the S3 bucket in the logs. But the attacker, with the administrator permissions, can change a little bit some flags. So, for example, only the CloudTrail will be monitoring only one region. And if you do for example, if you set up the crypto mining, the cryptocurrency miners in all of the other regions, they will be not notified only when the invoice comes from the Amazon. Of course, you can destroy the S3 bucket or destroy the trail, but then it is too loud because most likely they will get notifications that something doesn't work. In Pacu, we have again the special module to enumerate all the monitoring services. So not only CloudTrail, but also CloudWatch, GuardDuty, etc. And as you can see, there are flags like include global services, like creating a new user. So by default, it is true, it's set to true. The logs are validated. So if you destroy any logs, it will be detected by the CloudTrail. But using Pacu, you can minimize the CloudTrail, what means you will change those flags. Include global service events, false. Is multi-regional, false. So only the EU West one will be monitored, and in any other region, you can do whatever you want. Now, that's still not the end of the cyber kill chain, because now you, as an attacker, you need to have some backdoor. Of course, you can keep the backdoor in user data, but you shouldn't rely on it, because if the instance will be destroyed, then your backdoor too. Another approach to set a backdoor is to use the Lambda. For example, if companies, they are using a lot of Lambdas, from my experience, it seems nobody is monitoring if new Lambda is appearing, and nobody gives a shit how it is called. If they are called pretty the same, then nobody looks on it. And if you create Lambda that, for example, some event happen, then Lambda will be triggered and, for example, create a new user for you, and then you have access to the infrastructure. Even better idea is using trusting policy. The access in AWS is built on policies. And trust me or not, but not many people are reading policies. They are pretty boring documents. So once they are set up, nobody is verifying if they are changed. And you can use, for example, trust policy. So if there is a policy of role of admin, you can give the permission that this role can be assumed by totally other account. So, for example, yours, the attacker's account. So the attacker's account can just type STS assume role and gain the admin to your infrastructure. Another idea is to create an additional keepers. Now, question to you. How many keepers can be created to one identity and access management user? How many? Unlimited? No. 2, yeah. So the idea behind it is that when you are running some service and it uses keys, then, for example, those keys are compromised. So you want to change them, which is what is called key rotation. And if you want to rotate the keys, if it would be possible to set only one keeper, then you should stop the service for the moment of changing. But if you have 2 keepers, then you can which work the same, then you can put there and then destroy the first keys, and the service is continuously running. So again, in Paco you have a separate module for it. So you just putting run IAM backdoor user keys, and then extra keys are added to every user. And there's absolutely no notification that your user has extra keys. And even in the dashboard, there's no notification. This is the identity and access management dashboard. And there's a column access key age. And when you see that this user has the 5-day access key, right? Yeah, well, pretty okay. It even has the multi-factor authentication, so the beginner administrator thinks everything is okay. But later in the security credentials tab, you can see that there are 2 keepers, and the 5 days is regarding the older keys, right? So nobody sees that there are 2 additional keepers for this particular user. And the multi-factor authentication is usually just for console access. If you want to use the multi-factor authentication also for programmatic access using keys, then it requires the special policy, which will deny any action if there is no if there is no multi-factor authentication enabled, which is pretty rare. So how the story could end, I'm leaving it to your imagination. But there was one story. There was a company called CodeSpaces. Have you ever heard about it? In 2013, it was the raising alternative to GitHub. Now nobody remember this company, and I tell you why. Because they put everything, all the infrastructure on AWS. They didn't have any infrastructure on their local servers. Everything was in cloud. Let's go to cloud, right? And then the root accounts were compromised. And the guy, the attacker told them, either you will give me money or you will regret of not giving me this money. And they checked the logs and they really find this compromised account. So they removed this account and say, now what? And of course, he had the backdoor, and in revenge, he destroyed all the resources they had. And of course, they have even the backups they have under the same AWS account. So the company stopped existing in just one day. Well, but can we prevent such attacks? Of course we can. So the first concept is dynamically lock the credentials from metadata. So only using the metadata proxy, you can it will be injecting the session policy with the limitation that the metadata can be accessed only by this instance with IP of this instance, as well as the VPC ID in which this instance is run. So even if there's the server-side request forgery vulnerability in your web application, nobody can do anything with those keys. Funny fact about this is that the author of this solution is the William Bensington. Do you know this guy? He's the security guy. He was the security guy from the Netflix, and then he became the cloud security director in Capital One. And 2 months after he gained this position, there was one of the biggest breach in Capital One, and someone find the vulnerability, the server-side request forgery vulnerability, gained the keys with the simple with the S3 service access, and she just dumped all the data from the Capital One. 3 months later, someone detected the attack only because the data was already published. So there was absolutely no monitoring of such anomalies that someone is listing 700 buckets and then dumping all the content. So yeah, think about it too. The next thing you can do is using the AWS organization, and it allows you to separate accounts. So the best practice is to use at least 3 accounts under one organization. And for example, if your developers needs only access to EC2 or S3 service, you can limit the access to any other service using the service control policies, the SCP. So now, even if they become any of your developer become the administrator, he can do he cannot hurt you much. All the logs are going by the cross-account app replication is going to the logs, which are stored under second security or auditor account, and then you can do nothing with logs. Again, the next thing you can do is there is the AWS Center for Information Security Foundation's benchmark, which is generally the list of best practices you should follow. So, for example, there are such things like do not use wildcards, do not open security groups for public access, etc. And you can check it automatically. There are tools. If you are interested, I can give you some. You can just automatically check what is the configuration of your account. And the final thing you can do is set up monitoring. So if anything bad is happening, then you should have the automated incident response that will block the account, that will notify your incident response team, etc. Now, can we detect such issues? So in the cloud security assessment, I think we should follow at least those 4 steps. Which is the first is the architecture review. So verifying the best practices in the design. So if you are using the AWS organization, if there is the proper separation, if there is possible the privilege escalation paths, etc. Next thing is the configuration review. So verifying if your infrastructure is actually compliant with the AWS SIS Foundations benchmark. And the separate step during this process should be verifying the security of the sensitive services like the Lambda. So there's a totally new attack vector like event injection. Verifying code of Lambda, verifying the security of applications which are running on our infrastructure. And the final thing is verifying monitoring. Even if you have deployed all the security mechanism in your account and you don't have proper monitoring, you shouldn't feel secure. So for example, let's take again the Capital One. I'm totally sure that there was account which had the access to the to all those content of the buckets. But this guy can change his mind that he want to gain some extra money, whatever his motivation is. But it should be detected. It should be detected that one of your employee, consciously or not, is getting all your sensitive data, right? So to sum up, remember about auditing your cloud infrastructure, verify it, harden it, and then repeat. So remember, it's like the continuous process. It's not like verifying once it's done, then okay. The best approach is to automate this process. So if using, for example, AWS config, that if any change is done, then it is verified. And if something is not compliant with your own policies, then it is reverted back to the right status. So to give you, in the end, to give you some materials, here is my guide with some of the best practices in AWS. Of course, it's free. It's like 11 pages, so not big guide, but there are the most important ones. And also, if you want to play as a hacker, I've prepared the Capture the Flag game, which is built on our company infrastructure. So there's also the walkthrough if you have any problems, but also you can play and feel as a hacker. If you want to have more open source materials to learn from the offensive security perspective, just let me know. Drop me a mail and I will share it all. So that's all from my side. Thank you very much for your attention. And do you have any questions? Yeah. 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 So, for example, in Lambda is triggered. Lambda is triggered by events. For example, one way of privilege escalation, if you are using the managed, the Amazon managed permissions, there's a database role, the database policy, which gives you permissions only to create a Lambda, but not to trigger it. So you can create any kind of Lambda, but you are not allowed to trigger it. But using the event injection, you can create Lambda that it will be triggered by the event. So, for example, you are creating the database, and you are creating the event of appearing an entry in this database. So you are allowed to create the database. You are allowed to put the entry there, and this will be the trigger of Lambda, which will be executed. Even you don't have the permissions to do it, but using those events, you can. Another example is, for example, the Lambda code is taking the name of the S3 object and put it in the SQL statement. So you can name the object with the SQL injection, and it will be triggered. Yeah, examples like this. Lambda is very often used for the PDF generation or the picture, some modification of picture, and very often this code was never analyzed from the security perspective. Any other questions? Yeah. Mm-hmm. There are, yes. There are even the native Amazon solutions. So currently the best practice the Amazon says is using the security hub, because there is no one service of monitoring all the security events. So you should have guard duty, you should have AWS config, you should have AWS inspector, you should have AWS Macy, and you should have other services. And they found that actually there are pretty much of those services, so how to monitor them? So they created another service, which is called the Security Hub, to aggregate all those logs, and then you can, for example, simply plug the CM system, so whatever incident response you are using in your company. Of course, you can create your own, for example, regarding the SIS benchmark. In just few clicks, you can create a template in CloudFormation, and you can deploy it. So all the AWS config rules will be deployed regarding the SIS benchmark. And if any of your developer will, for example, put the security group open to public access, you will be notified. Yeah, and you can, for example, like get notification on SMS, mail, whatever. Yeah. Well, I'm not the expert in Azure and GCP. I will be honest with you. However, there are some drawbacks too. Because it is related with the human factor, because it's easier to set up the insecure environment. However, regarding the server-side request forgery, in GCP and Azure, it is not so easy, because you have to add the special secret value in the header. And in Amazon, you don't have to. So, vulnerabilities like this work like a charm, and in Azure and GCP, it's not so easy. However, still, if you have some kind of remote code execution, you can do exactly the same. Yes, please. Mm-hmm. I don't think so. It will be changed. It's like, because Amazon doesn't see vulnerabilities in all of these things. So, for example, user data and cloud boot hook directive, they can be used by attacker, but the problem is Amazon always will tell you that, well, those guys have access to your infrastructure and they are using the features. So, you know, they don't see a problem here. There are a lot of nuances, security nuances. So, for example, the phishing attacks on the Amazon. This is awesome, and I don't know why Amazon is not doing anything, because if you click the Remember Me when you are logging to the AWS console, then this persist cookie will be will also work even if you change the password, right? Which doesn't make sense because, hey, I got compromised, and the attacker, hey, I don't care because the persist cookie still works. Yeah. Thank you very much. Enjoy the event.